Hi, that is Ian Walker. In today's electrochemistry lesson, we will be focusing on oxidation and reduction. And in my hand here, I have two AA batteries pulled out of my TV remote. And these batteries nowadays are used for everything, and we rely heavily on them. But what goes into these batteries? In these batteries, they're electrochemical cells, which are systems that produce electric energy. Here's a diagram of an electrochemical cell. And electrochemical cells have many complex components, but for the purpose of this lesson, we only need to focus on a couple of them. We're going to break this down into two half cells. And each half cell has its own separate half reaction. And these two reactions, they're different from each other. One side of the electrochemical cell is an oxidation reaction, and the other side of the electrochemical cell is a reduction reaction. And when there's an oxidation reaction and a reduction reaction occurring at the same time, electrons are flowing, and that is what causes energy to be produced. Now, what are oxidation and reduction reactions? An oxidation reaction is a half reaction in which a species loses electrons, becomes more positive, if you may. A reduction reaction is a half reaction in which a species gains electrons. And an easy way for me to remember this is a simple sentence. Leo the lion says grr. And I use this sentence while I'm working through problems and other things, and it just helps me remember what exactly oxidation and reduction reactions are. So Leo breaks down into loss of electrons is oxidation, L-E-O. And grr breaks down into gain of electrons is reduction, G-E-R. And while you may not use this in your problems, I just find that it helps, and I recommend using it. Now, when the two half cells are combined, one side oxidation and one side reduction, they form a redox reaction. And redox simply breaks down into reduction-oxidation reaction. And a redox reaction is any reaction where there's a loss and a gain of electrons. Here is an example of a redox reaction. Here we have 2Ag plus Cu goes to 2Ag plus Cu 2 plus. And we can see here that Ag starts off with a +1 charge and ends here with a neutral charge. So that means it's becoming more negative, which means it's gaining electrons. And so we can tell that Ag here is being reduced. And Cu starts with a neutral charge and ends with a 2 plus charge. Therefore, it is losing electrons. Therefore, it is oxidizing. And these different components are called different things. We call Ag plus the oxidizing agent because it causes Cu to oxidize. And we call the Cu the reducing agent because it causes Ag to reduce. So if you think about it, an oxidizing agent will reduce and a reducing agent will oxidize. So it's kind of reversed. Here's how we identify oxidations and reductions in reactions. There are a couple simple rules that we can follow. A species being oxidized becomes more positively charged in the reaction. So if we look at these half reactions here, we have Zn, neutral charge, goes to Zn 2 plus. So we can see that it is becoming more positively charged, and therefore we can determine that it is being oxidized. Same here, we have uranium 3 plus, goes to uranium 4 plus. So it gains positive charge. Therefore, it's being oxidized. And on the other end, a species being reduced becomes more negatively charged. And we can look at an example here. Cu2 plus goes to Cu, neutral charge. Or we have vanadium 3 plus goes to vanadium 2 plus. And so because this is becoming more negatively charged and gaining electrons, it is being reduced. So now let's work through 3 examples knowing what we know to use our skills to see which of these are being oxidized or reduced, and which ones are the reducing agents or the oxidizing agents. So let's take a look at number 1 here. We see that zinc has a charge of 2 plus to start and has a neutral charge. And then Mg, neutral, ends with 2 plus. So zinc is becoming more negative. And becoming more negative, we know that zinc is being reduced. Mg starts off with a charge that's neutral and ends with a 2 plus charge. So we know from Leo the lion says Gur that loss of electrons is oxidation. So it's losing electrons, becoming more positively charged, so it is oxidized. And also we know that whatever is reduced is the oxidizing agent. So oxidizing agents are reduced. So we know that this is the ox agent. And reducing agents are oxidized. So we know that this is the reducing agent. I'll give you a second to copy that down. Now let's tackle question number 2 here. We have Hg, which starts with a charge of 2 plus and is on the other side with a neutral charge. And we have Mn, neutral charge, and it ends with a 2 plus charge. So we know that Hg is becoming more negative, therefore gaining electrons, and is being reduced. And Mn starts with a neutral charge and ends with a 2 plus charge, therefore it's losing electrons, and therefore we know it's being oxidized. Now which one of these is the reducing agent and which one of these is the oxidizing agent? Think back to question number 1 and the rules that we have discussed. Reducing agents are oxidized. So we know that this is Mn is being oxidized, so it is the reducing agent. And Hg is being reduced, so we know that it is the oxidizing agent. Finally, question number 3. We have 2 Li, neutral charge, and F2, neutral charge. And looking on the other side, we see that Li ends with a charge of positive 1, and F ends with a charge of negative 1. So we know that Li is losing electrons and becoming more positive. So we know that Li is being oxidized. And F is becoming more negative, therefore gaining electrons. F is being reduced. And from this, we know that oxidizing agents are reduced. So F is the oxidizing agent. And reducing agents are oxidized. There are a couple examples that we have worked through, and I hope that you guys have learned a lot, and stay tuned for more videos.